Hello everyone, Top Hat Waffle here once again to continue working on our Counter-Strike Global Offensive competitive level. Today we will be adding more advanced lighting to our level. This will be the third and final part that will cover lighting in Source Engine. We'll continue where we left off in DE Metro last time. We need to open up Hammer first, so under the Tools section of our library, open up the CSGO SDK, load Hammer World Editor, and off we can go. The first thing that I want to take a look at is the NV projected texture. Support for this entity was added back in with dynamic shadows during the Wildfire update. To really show how cool this entity is, we'll fly over to a dark area in our level. There's currently nothing in the level that I want to point this entity at to utilize its shadows, but later on in development, you may place this behind a fan that's spinning or something that's a point of interest to the players. Start by grabbing your entity tool and place a new entity on the ground. Double click on it and change its class to NV projected texture. Much like the light spot entity, we get a cone depicting where the light's going to go. We can adjust this cone using the FOV value. For now, I'll just put it into place pointing this way, and I'll tighten its FOV by just lowering this value. We can see that cone has gotten smaller as well. We have two other values, which are the near Z and far Z. The far Z is the distance that the light will be cast. You'll need this to be larger or smaller depending on where you're putting it. The reason that we have a far Z on this is to prevent shadows from being cast to infinity from this entity. The near Z value is where light starts to be cast from. If I turn this value up to something like 16, we can see this lightly shaded area. Light only starts to get cast from this dark shaded area. We'll want to tick Enable Shadows and Yes. We can only have one NV projected texture active in our level at a time. This is a Source Engine limitation, and you cannot work around it in any way. You can have more than one NV projected texture in your level at a time, but only one can be active at a time. Let's make another copy of this entity so I can show you guys what I mean by only one active at a time. If we shift drag it over, I'll rotate it, and just change its color to red instead of teal. We'll use the name field to name this one red, and the name field on the other one to name it blue. On the red light, we want to go to the Flags tab and uncheck Enabled. This will have this NV projected texture start off by default. Click Apply, let's unhide everything else, compile, and check it out in game. And here we are in game. If we come over here, we see that we have our blue light and its shadow in the background. I'll open my console and I'll enable third person by just doing third person. You have to have SV cheats on for this. And we see that we have my player shadow, which arcs around the origin of this light. We can use a console command to turn on the red light, so I can show you how only one can be active at a time. If we use the console command ENT_fire, which allows us to fire inputs and outputs to entities in our level from the game, we type red and then turn on. This automatically turns off the blue NV projected texture because of that hard limit in Source Engine. This light functions exactly the same. We have our dynamic shadows, but like I said, it turned blue off. If we turn blue on, it will disable red. This makes you have to be very particular on where you want to put this entity if you want to use it, which is why you'll want to put it behind something that's moving to give better ambiance in your level. The next thing that we're going to look at is emitting light from a brush using the lights.rad file. This effect works great in CSGO and has also been used in the Portal games to give the lighting around the edge of the test chambers in a track. While inside of Hammer, we're unable to see what brushes will emit light. If we open up our game directory and look for lights.rad and open it with a text editor, we can see that there's a list of textures here along with red, green, blue, and intensity values. If we look and we see DE Nuke, HR Nuke, Window Illume 001, this is a texture that will emit light when applied to a brush. Let's go ahead and browse for this texture right now. I'll select this texture and I'm going to use it to light my vent. I'm imagining that this vent extends outwards to the outside, but I want custom lighting that's not going to be based off of the light environment. We can right click to apply the texture, and it looks pretty much just white. If we switch our camera mode to 3D light map grid, each one of these light map luxels is how light gets emitted from these textures. Each luxel is one emission point. If you set the light map grid lower, you'll have more lights emitting from it, but this also increases your compile time. I'll leave mine at the default of 16, as that's pretty good in most cases. Let's go ahead and hit F9 and we'll compile it and see how it looks in game. Here we are in game. If we come over to the vent, we have our lighting coming from our brush texture. Now, what if we wanted to customize this light value? Going back to Hammer, if we open up the lights.rad file, we can just change this value. I'll copy this entire line, comment this one out, so if I want to revert back, I can do so. Paste this in, and let's just make this be a much more red light. Remember, this is red, green, blue intensity. If I set the green down to maybe 40, and again the blue down to about 40, this should be pretty red. I'll also bump the intensity up to maybe 450, and then I'll save the file. The lights.rad file only contains the information that VRAD needs to compile this light. This means that no one else ever needs this lights.rad file after your level is compiled. Let's take another look at this in game. Here we are back in game. If we come into our vent, we can see that this light is emitting red with that lights.rad file change. Next, let's take a look at smoothing groups. Smoothing groups, if you've ever used 3D modeling software, will make the lighting smooth across faces that are curved. Take note how on these barrels, the lighting is very sharp when the shadow changes along the faces. There's a console command that we can use to better visualize lighting in our level. If we open the console and type matte full bright 2, this will turn the entire level into grayscale only. This is a great way to visualize just the lighting on your level. In this mode, we can very easily see that the lighting changes sharply from this face to the other face. Over in Hammer, let's smooth this top barrel out. For this, we'll want to switch to our light map grid view. I'll hide everything except for these barrels, and then open the face edit sheet. From here, let's select just this top barrel, and then deselect the top and bottom faces. Logically, on a barrel, the sides are not smooth with the top, so we don't want to smooth them with the sides. If we click the smoothing groups button, we'll get the smoothing groups dialog. We have the option for 24 different smoothing groups and 8 different hard groups. Hard groups are picked just like smoothing groups, and they do the exact opposite of them. You use them to tell faces to never be smoothed with each other. For example, you can use them to make sure that a ramp will never be smooth with the adjacent faces that it connects to. When adjacent faces are applied to a smoothing group, the lighting engine will automatically smooth the light out when VRAD compiles the light. Let's place all these faces in smoothing group 1. When we've applied the smoothing group, the 1 will be depressed when we select a face in that group. Now let's smooth this barrel down here. Doing the exact same thing, selecting just the sides, let's put it into smoothing group 2. We don't want this top barrel to smooth with the bottom barrel down here, so they need to be in different smoothing groups. Lastly, let's select both of these barrels and change their light map grid scale to 8. You'll need to lower the light map grid scale to get smoother lighting after you've applied a smoothing group. Start with the value of 8 and work lower and lower until you get the smoothing effect that you want. Don't go too low though, because as I said in the previous video, the lower the light map grid is, the more compile time it takes to process that lighting and the more strain there is on the engine. These two barrels are unsmoothed. For comparison's sake, let's select this one barrel and also give it the light map grid of 8. This will allow us to compare our two smoothed barrels with the light map grid of 8, a default barrel unsmoothed with the light map grid of 16, and a unsmoothed barrel with the light map grid of 8. Let's unhide everything and switch our camera mode to 3D Smooth. This will give us the same smoothing group dialog that we had before. But if we click on one of the smoothing group buttons, it will highlight objects and faces that are applied in this smoothing group. Let's go back to 3D textured and compile it so we can see what it looks like. And here we are back in game. Up top we have our 2 barrels with the light map grid of 8 and the smoothing groups. This is the default barrel of 16 light map scale with no smoothing. We can see it still has the hard edge, whereas the smooth barrels almost look like they're perfectly round. While you won't get near perfectness in a video game, this does look much better than this. Over on the other side, we have the light map grid scale of 8 with no smoothing. This is better than the 16 light map scale, but it's still worse than the smoothing groups. If we turn matte full bright to 0, we can see how these objects look with their textures applied to them instead of just lighting information. We still see those hard seams, and these look way better. Now let's take a look at our blending options for lights. We'll use this light as our guinea pig. Let's start with the 50% and 0% fall-offs. We have to set both of these to be used, and the 50% needs to be inside of the 0% fall-off. This setting is pretty self-explanatory. It's the distance at which brightness should fall off to 50% of the value here. If I position my camera in the 3D view and click this little camera button, it will automatically input the distance from my camera to the light. If I click apply, this little circle will be drawn around the light in my 2D and 3D view. If you don't have that, you'll need to make sure helpers is enabled at the top. We can drag this to make it bigger or smaller, and then let's click it again for the 0% and click apply. So we have the 50% on the inner and the 0% on the outer. Let's take a look at that and compare it to what it is with the default settings. This is the default light with no 0% or 50% fall off set or other blending options. And here's the light with the 50% and 0% fall off that we just set. It appears much brighter because the 50% fall off distance that we set is larger than the light would otherwise fall off to. Now let's look at the more advanced blending options that we can use. Before we can use the constant, linear, and quadratic blending options, we have to set the 50% and 0% back to their default values of 0. If these are set, constant, linear, and quadratic blending options will be overwritten. By default, all lights are quadratic 1 with 0 constant and 0 linear. Let's take a look at what 0 quadratic and 1 linear is on a light. This is a full linear light. Its fade off is much more gradual than the quadratic light. Where quadratic lights are quite bright and fall off more rapidly, the linear light follows a more linear decline in brightness as the distance is further from the emission point. Now what does constant look like? Constant is a little bit different than the quadratic and linear, where constant will emit light to the ends of the earth. Let's set constant 1 and take a look at that in game. This is a full constant light. You'll notice that the light is pretty much the same brightness no matter how far away from the light emission point we are. In fact, if we look over here, this wall back here, even though it's much further away than the closer walls, has the same amount of brightness. To take it one step further, if we look out here, it's a little washed out from the ambient. There's a slight glow of light coming through the door frame right in front of this box. This is why when we use 100% constant lights, we want to use them at lower intensities for almost ambient lighting inside of areas. The last thing that we need to configure is HDR. Unless you want 1.5 million Reddit threads created about your level because no one can see anything like it's vertigo, you'll want to do this. Let's start by placing a new entity, and I'm going to do this over by my global entities that I did earlier on. This first entity is going to be an NV tone map controller, and we're going to give it a name of @tone map. The @ does not have any significance here. I just like to prefix my global entities with the @ for organizational purposes. We also need to create another entity that will be a logic auto. Click apply, and we just need to compile the level again with these entities present so we can fire some commands to them to tweak the settings live in game. Here we are in game. We're going to end up firing 4 different commands to our @tone mapper that will configure HDR for us. The first one that I want to set is my auto exposure max. So I'll open my console and I'll type ENT fire @tone map, set auto exposure max, and I'll set this to 4. we don't see anything change. What this command does is when you go from areas of darkness to brightness, HDR will expose more, like your pupils will dilate, and slightly blind you. If we look at this wall, we can see everything just got brighter. This is the simulation of our pupils adjusting to the darkness and everything becoming easier to see. When I flip around, everything is extremely bright for a moment and then dulls down. That's a bit extreme, and what I'll do here is I'll set this to 0. I'll now use set auto exposure min, and I'll set this to 2. What I'm using this value for is by setting the minimum value for the exposure, I'm going to tweak this value to be the max amount exposure that I want. So I'm using exposure minimum to find the maximum value. That may be counterintuitive, but once I find the value that I want, I'm going to go with 2.8. This may seem rather high, but we'll just copy that and throw it into a notepad file and save it for later. Next, I'll set the exposure min back to 0, and I'll now set my exposure max to the 2.8 that I want. Now I just want to find my minimum exposure. If I set my exposure minimum to 0 and then use maximum, I can set that to find the maximum amount. So we use minimum to find our max and maximum to find our minimum. So I'm going to go with 0.35 for my minimum. So I'll get that value, 0.35, and save that. And then I'll put both of these to their actual values. So I'm setting my maximum to 0.28 and my minimum to 0.35. Everything may still seem a little bit overexposed. The next command we're going to do is set bloom scale. Now, if you're wondering what this does, it's the scale of the bloom. If we blow it out by setting it to 100, that's obviously not great. So let's set it down to a lower value. 0.25 actually seems pretty good. I'm not getting obscenely blinded when I go from darkness to brightness. That's a little bit... So you want to test some areas like that. That is a little overexposed. So I can just change my maximum here from 0.28 to 0.225. It's a little bit better. We can kind of keep tweaking a little bit. So I'm going to settle on exposure max of 2. And then the last value is the tone map rate. The rate is how fast your exposure will change. So when I look at the dark area and then flip around, it's how quick everything will adjust. If we set this to a low value, it's going to come up super slow and then drop off super slow. I'll set this to 0.35 as that's a good starting point. Now we just need to have these settings be applied to our tone map on map spawn. Double click on our logic auto and go to the outputs tab. Click add, and for my output name, click on map spawn. This will tell the logic auto to fire this output when the map spawns. Our target entity will be our tone map, and via this input is the command that we want to fire. Let's choose set auto exposure max, and we're going to set this to a value of 2. Next, let's just click copy and paste, and we can change auto exposure max to auto exposure minimum, change that to 0.35, copy paste, the bloom scale to 0.25, and then the tone map rate to 0.35. Click apply, and let's compile for the last time. Thanks for sticking it out through all 3 parts of the lighting tutorial. I really hoped it brightened your day. We placed a lot of happy lights, made a few happy accidents that turned out to be just alright. Thanks for watching. Don't forget to join us again tomorrow for the next one.